So, conservation of momentum, example 2. Cart A with a mass of 0.5 kilograms is traveling at a rate of 1 meter per second when it hits the motionless cart B with a mass of 0.5 kilograms. Construct a momentum bar graph to determine how fast the coupled cars are traveling. Now, this problem is going to be a little bit different than example 1 because we're actually trying to solve for something. For this problem, we're going to be using the momentum bar graph to determine how fast the coupled carts are traveling. But before we get to that final one, we're going to do the exact same setup as what we just did. First step, specify the impulsive force event that separates the initial and final situations. Well, what's happening here is cart A is traveling at a rate of 1 meter per second when it hits the motionless cart B. So this right here is going to be our impulsive force. That is going to be a collision, and because these two things don't bounce off each other, it is going to be a completely inelastic collision. So that is what we are going to have for our initial situation. For our event, it's the inelastic collision. Then after that, we're going to go to step 2, designate objects in the system by listing the object, its mass, and its velocity in the chart. Use variables for unknown quantities. Well, we are going to start off with cart A as our first object. Cart A has that mass of 0.5, and then all of these are going to be in kilograms. And then the velocities should all be in meters per second. It is traveling at that rate of 1 meter per second for its velocity. And because I'm showing in my diagram at the top of this page that I ended up drawing that it's traveling to the right, I'm going to say that that is going to be a positive velocity, positive plus 1. Cart B is the other object that we are starting with. Cart B also has that mass of 0.5 kilograms, but it is motionless. If it is motionless, we're saying that it has an initial velocity of 0. At the end, we know that these two things become coupled together. So I no longer have cart A or cart B. Instead, I have a different object. Cart A and B combined. I know that their combined mass is going to be the mass of cart A plus the mass of cart B, which is how we're going to end up with, instead of 0.5 plus 0.5, we can just end up simplifying that down to overall, that added together is going to be 1. They have a mass of 1 kilogram. And we don't know how fast they're traveling. That's what we're going to be looking for. So I'm going to be solving for my velocity. That can be my final velocity. It can be v just for velocity, or I can even have it as v of our A plus B cart combined. Step 3, draw a horizontal bar to represent the size and direction of the momentum for each object. Remember, our momentum is mass times velocity. Cart A, at the initial situation, has a mass of 0.5 and a velocity of 1. So we're going to have some positive momentum. I'm going to say that that is going to be 2 bars. Cart B has a mass of 0.5, but it has a velocity of 0. So I'm going to say it has 0 momentum. So when I'm representing it this way, I'm starting off with 2 bars for my initial momentum. In order for momentum to be conserved, that means I have to end up with 2 bars as well. I know that I have a mass for the coupled carts, but I don't know what the velocity is. I do know that I need to have a positive 2 bars, so I'm going to add that to my coupled vehicles, my coupled carts. We have 2 bars of momentum for the, cart A and cart B coupled together. Step 4 is to write the conservation of momentum equation for the bars and solve for the unknown quantity. Well, for that equation, in order for this to be conserved, it is going to be our initial momentums are equal to their final momentums, or the mass of cart A times our velocity of cart A at the beginning, plus mass of cart B times the velocity of cart B at the beginning, is going to be equal to the combined mass of cart A and cart B at the end times our velocity of cart A and cart B at the end. This is going to show that momentum is conserved from our initial to our final situation. I'm going to now plug in the values that I know and solve for our unknown quantity of the velocity. Mass A is 0.5 kilograms. It is traveling at a rate of 1 meter per second, plus our 0.5 kilograms for mass B times its starting velocity of 0 meters per second. That is equal to the combined mass of carts A and B when they're coupled together, 1 kilogram, times our velocity of A plus B. 0.5 times 1 is 0.5 kilograms times meters per second, plus 0.5 times 0 is 0 kilograms times meters per second. That is equal to 1 kilogram times velocity of A plus B. I'm going to simplify this down. The left side, 0.5 plus 0 is still 0.5 kilograms times meters per second, and that is going to be equal to 1 kilogram times our velocity of the coupled carts. In order to get that velocity by itself, I would divide both sides by 1 kilogram, which would cancel out the 1 kilogram on the right, and that would remove the kilogram from the left. 0.5 divided by 1 is 0.5. The only units that are left are meters per second, and that is going to be equal to our velocity of the coupled cart. So we ended up using this momentum bar chart to organize the information we knew: the mass of cart A, the mass of cart B, velocity of cart A, velocity of cart B, as well as the mass of the combined cart A and cart B when they're coupled together. We were able to use that and the conservation of momentum to ultimately determine how fast the coupled carts would be traveling at the very end.